We will understanding about what is the convergence algorithm, right? In previous video, we understanding about the how do we get a best fit line, what is a simple linear regression. But now, we get a best fit line, how we are changing the theta value. But in that particular case, in conversion algorithm, how we decide the value of theta? That is a question. So we just writing now how to um, find theta 1 value. That is your aim in this particular video, right? Same in that case, the base fit line passing through origin, it's mean theta 0 is equal to 0. Okay, theta 0 is equal to 0. And this function, this function will repeat, okay, repeat until convergence. Repeat until convergence. And we're writing one statement here is theta j. We are finding value of theta, right? Is equal to theta j minus alpha. What is alpha? We will understand in this video also. And this is we calculate the derivative of theta j with respect to j of theta j, right? That is your final aim. Okay. So how we calculate we understanding one by one. So first we plot a graph. Okay. We simply plot a graph. We simply plot a graph. In that particular case, let's consider we have a gradient descent, something like that. Okay. So this is our gradient descent, and in that particular case, and this is a global minima. Okay. Global. This is our global minima. So this is our global minima. Okay. This is our global minima. So in that case, we are considering. Let's consider with that is the theta j, and this is the j of theta j. Okay. So in that case, we have theta value someone like here. Okay. So we are calculating that point of theta. Okay. So we do derivative. Derivative. Okay. When we calculate the derivative, it's been basically the derivative. It's been basically calculating the slope, right? Derivative. It's been we calculate simply the slope. So in that particular case, when we calculate that slope of that particular line, okay. So this line, we calculate the slope of that particular line for the converging, and we find out, we aim to find out the theta value, right? So we for that theta value, we calculating that's the slope of that line, okay? Slope of that line, and this line is a tilt in a left hand side. It means the slope is a negative, okay? We are writing in that here the line of slope is still in left side. Its mean slope value are a negative. Are a slope value are a basically negative. Okay. Similarly, slope value are a negative. So what we look, we simply with that we have formula, and simply what is the derivative of j theta of j with respect to j of theta j is when we this is a negative. Okay, this is a negative value. So in that particular case, that's conversion algorithm or finding out the theta value, that's looking something like that. Okay, so this is a theta j is equal to theta j minus alpha, and this is a negative value. Okay, so this negative and this negative become a positive. So in that case, we simply increase the theta j value. Oh, we simply increasing theta j value. Value theta j value. It means in that particular case, uh, when we find out the gradient descent or the best fit, good best fit line, for that at that particular point, that theta value, what we'll do with the theta value, the theta value will be increasing or maybe sometimes decreasing, right? But when you calculate the slope is a tilt in the left hand side, so is a we getting a negative value. It's mean when we get negative value of slope, so in that particular case we simply increase the theta value, right? And it's come closer, and this come closer in a second time with theta value here and then here. Okay, we are simply increasing that theta value. Okay, and similarly, what happen when you find when you the theta value is the someone else here, okay, and this best field line, the slope line is a till in right hand side. So in that particular case, the slope is a positive. Okay, it's mean when the when the slope is positive, when the slope is positive, so simply derivative of theta j is theta j with respect to j of theta I is a positive. In that particular case, we simply write as j theta of I is equal to j theta of I minus alpha, and this is a positive. It means we simply decrease a theta j value. In that case, we simply when the slope are positive, in that case we simply decreasing the theta j value, right? And we uh, finally get a gradient descent. Okay, finally getting a gradient descent for the calculating the theta value. Okay, and what is the alpha? Alpha is basically learning rate. Okay, what is the alpha? Alpha its value is 0.001, and this is basically a called a learning rate. Okay, this is the learning rate, and this is useful to control the convergence of theta value, right? When we okay, in that particular case, when we don't have a alpha value, right? So theta value may be convergent something like that. Okay, something like that. So for that, that theta value not converge that much speedily. That's why we using the conversion algorithm. Sorry, learning rate for to control alpha is for the control the convergence of theta j value, right? This is useful for the control the convergence of a theta j value. Okay, this is for the convergence